Hello everyone. In the last tutorial we created a window using Miniquad. But a window is not as exciting as a triangle. If you've ever seen the OpenGL triangle, it's a sight to behold, and we're going to create that in this tutorial. But first, the triangle needs vertices, so let's create a vertex.rs. Inside of this, we'll write struct or pub struct vertex, and it takes a position which is an f32 2 and a color which is f32 4. Before I explain why, we'll first do mod vertex to add this into the main.rs, and we're creating a public struct called vertex. The vertex takes in a position, and the position is just an X and a Y. And the color is actually a RGBA, the A standing for alpha. These are just float 32s, and this is basically what our vertex looks like right now. But the GPU doesn't actually know how to handle these types of structs. The memory may be color first and then position, or position color. The GPU doesn't know that, and Rust won't do that by default. So we have to tell it to do that. We'll first write hashtag, square brackets, repr, and then C. Now, that works, but writing vertex each time, writing all of this, is a little cumbersome. I'll make a public fn vert, which takes the position f32 2 and the color, which is an f32 4 semicolon. This returns a vertex, and we can just pass in this position and color to the vertex. Cool. Now, in the stage, before we just had a simple context, which was a GL context, now we actually want a full-on rendering backend. So replace this with a box dynamic, which is din rendering backend. In here, we'll get rid of the stage entirely, and we need to create the rendering backend. This will be a let CTX equals to window, the window library from Miniquad, new rendering backend. This is the box thing we just created. But we don't need just the CTX. We need a pipeline and a bindings. So we'll write pipeline, which is a pipeline, and bindings, which are bindings. The pipeline just gives us extra information on how the GPU should draw something, and bindings are data like shaders and any textures that we want to send over to the GPU. So let's create the vertices. We'll write vertices, and I'll write it using these blocks just so it's easier to see. Let vertices equal to an array, but it doesn't know what the array is. We'll write vertex semicolon 3, because guess what? A triangle has 3 vertices. So we'll write vert, but we haven't imported that, so we'll write use rate vertex star. We'll write vert. For the position, we'll write -0.5, -0.5. For the color, we'll write 1.0, 0.0, 1.0, sorry, 0.0, and then 1.0. This is just red. Same thing 3 times, and we'll just change this to be positive 0.5, and this will be a 0. And this should be positive 0.5. So this is the red, this is the green, and blue. And I'll color those accordingly. Like that. But vertices alone isn't enough. We can't really send this data to the GPU like this. So we have to create what is known as a vertex buffer. So right, let vertex buffer is equal to ctx.newBuffer. The new buffer is a generic function which takes in the type, the usage, and the data. So the type of the buffer is a buffer type, which is the index buffer or the vertex buffer. We will do the vertex buffer. And buffer usage just means how we're going to use the data that we're sending over. So this is a buffer usage immutable. There's 3 types of these: buffer dynamic, stream, and immutable. We're not changing any of the data. This is all just constant pretty much. So we're setting this to immutable. Then we have data, which is the vertices that we're sending, which is a buffer source slice. But make sure you make this slice lowercase, not uppercase, and a reference to the vertices. Cool. But we also have to create indices. The indices tell the GPU how to make the triangle using the vertices. So we'll write let indices of type U16 and 3 is equal to 0, 1, 2. So this just says a triangle is made up of the first one, the second one, and the third one in that order. But we also have to send the indices to the GPU, so we have to create an index buffer. Index buffer is equal to ctx.newBuffer. This time we'll use buffer type index buffer, buffer usage mutable, and the data is a buffer source slice with a lowercase s, and this will be the indices, semicolon. So now that you have vertices and indices, we have to write the shader that we're going to use. The shader is what tells the GPU where to place the vertices and also where to how to draw the pixels on the screen. So let's create a new shader.rs. We need to use Miniquad ::* and use the std::fs. Also make sure to mod shader. The fs stands for file system, and it basically just allows us to load files from the file explorer into our project. So I'll make a pub-fn load shader. It takes a path, which is a string slice, and returns a string, the string object. We'll write fs read to string, passing in the path, and this returns a result. So in case if it fails, we just have to write a reference to we'll format failed to read shader as in path, like that. Don't put the semicolon. Also, since we're doing all of this, let's also create a shader meta file. Shader meta function, which returns a shader meta object, and this is just shader meta The shader meta tells us what uniforms and images we are going to send. So we don't have any of these. We'll write for the images, we'll send an empty vec and for the uniforms, uniforms is a uniform block layout, but the block layout takes a uniforms, which is also an empty vec. That's the meta and this load shader. So we can go back into stage and create the shader. Let shader is equal to ctx.mapShader. The shader and the meta are required, so what we're going to do is shader source, and it can be GLSL or MSL. GLSL is what we're going to use, but if you're an Apple or iOS device like a Mac or iPhone, you'll want to use MSL, which uses the Metal programming language. GLSL is the OpenGL shading language, and it takes the vertex and the fragment shader. We don't actually have those yet, so let's write them. Shaders, a new folder, and we'll write vert.glsl. How GLSL works is a bit complicated. It's like the C programming language. We'll write version, which is 100, and we take an attribute vec2 called in position, an attribute vec4 in color, and a varying low profile vec4 called color. Also, we create a void main in which we write GL position is equal to vec4 in position 0, 1, and color is equal to in color. We pass in the position and color of the vertex, each vertex, and we set the color of the vertex to the color that we specified here. Let's also create a fragment shader called frag.glsl. The vert.glsl, by the way, runs for every vertex, and the frag.glsl runs for every pixel on the screen. So even this requires a version, and we'll write varying low vec4 color. In the void main, we'll write GL frag color is equal to color. And that's all the code we need for the shaders right now. So we can go back to stage and write vertex. Go back here and use create : shader : star. Then we'll load the shader using the function down here. Load shader the path is the source / shaders / vert.glsl. The fragment shader is the same thing, but it's frag.glsl. It also requires the shader meta. That's of course shader meta. That's a shader, but we need the shader ID. We don't want the result. So we'll just unwrap this. In case we can't create the shader, or if you use MSL where you're supposed to use GLSL or vice versa, this will give you an error, but it's fine for us. So we'll write the bindings now. Bindings. Let bindings equal to bindings, and in here it requires vertex buffers which is a reference to an array. Wait, is it a reference to an array? No, it's a vec, which takes in the vertex buffer, and there's only one index buffer, so we just pass in the index buffer, and images, which we don't have any, so we'll put an empty vector. Those are the bindings, but we also need the pipeline. So we'll do pipeline. This, of course, tells us what we are sending to the how the GPU is going to render everything. So this is pipeline is equal to ctx.new pipeline. And this one's a little bit difficult to understand. It is a reference to an array of a buffer layout, which is the default one, and the attributes that we're sending over. Vertex attribute, new, in pos, or in position, and vertex format, float 2, and if you can guess, it's in color, float 4. These are the same vertex attributes that are in the vert.glsl, in position, in color. And vec2, vec4 is float 2 and float 4. Now, it also takes the shader. So we just pass in the shader and the params. Pipeline params have a bunch of stuff that you can do, like depth testing and culling, but we'll just write pipeline params colon default and end the semicolon. Now that we have the pipeline finished, we have to actually address this error. We have to return the stage. So what we'll do is we'll create the stage, pipeline, bindings, and ctx. Cool. But since we're using this in the stage, it says cannot mutate immutable variable ctx. To fix that, just add mut up here, and we're good. Now, if we run the cargo project, it's still just a red. I'll remove this. It's a black window. Why is that? Well, we're not actually drawing anything. So to do that, we'll do self.ctx.begin default pass. And we don't do anything in the pass action. Then we do self.ctx.end render pass and self.ctx.commit frame at the end. Render pass is just a sort of sequence of how you render stuff. Like a bunch of game engines will render things in different batches, so you might have a render pass for all of your meshes, and then a render pass for any shader effects or post-processing, and anything else such as particle systems will go on top. It's just a sort of series of passes or events that do the actions that they're supposed to do. But you may see this warning: pipeline and bindings are never read. Well, let's do that right now. Self.ctx.apply pipeline, a reference to self.pipeline, and self.ctx.apply bindings, a reference to self.bindings. Cool. But we also have to actually draw the triangle, so I'll run self.ctx.draw. This takes the base element, number of elements, and num instances. The base element specifies where we want to start from in the index buffer. The num elements specifies how many things are in the index buffer, and the num instances is how many instances should be rendered. Usually you'll just put 1. So if you look here, the indices have 0, 1, 2. It has 3 values, so we'll have to draw. We'll have 3 things to worry about. Base element, we're starting from 0. There's 3 things in the indices, and number of instances is 1. If you do all of this, and then run the project, you'll have a triangle. That's amazing. We just made a triangle. Yeah, that's pretty much it. You don't need to do anything else. In the next tutorial, we can have a quad. If you want to try changing the positions or the colors of the triangle, feel free to do that. And one more thing, if you set this to -1, -1.0, this goes all the way to the left. And same with the other side. So that's how you draw a triangle using Miniquad. It's actually very simple, way simpler than using OpenGL. And I hope that you like this tutorial. If you want to see more, comment, like, subscribe, all that. And see ya.